Hello students, welcome back to Learn 24. From this video, we are going to start our new chapter called Solutions. In the last video, we saw an overview of this chapter, right? So we all know what we are going to study in this chapter. With that concept in mind, let's begin our chapter Solutions. First of all, I will give you a definition to the solution. Solutions are the homogeneous mixtures of two or more components. Now the question arises, what is a homogeneous mixture, right? Let me give you an example. I have a glass of water with me and I added some salt to it and I mixed it very well. Now all the molecules of this salt are uniformly distributed throughout the solution, right? All particles are dissolved very well. It's called a homogeneous mixture. Now, the solution must contain two or more components. At least it should contain two components in it. What are those two components? The solvent and solute. The solution must contain one solvent and one or more solute in it. What is solvent and solute? Solvent is the component that present in the highest quantity or the larger quantity, and the solute is the component which is present in a lower quantity, or the component which is dissolved is called dissolute, or the component which dissolve the other component is called the solvent. Clear? The water is dissolving the salt and it is present in the larger quantity, and the water will be our solvent. And the solute, salt is present in lesser quantity and salt is the component that dissolving. So the salt will be the solute. Clear? And solutions, sugar in water and salt in soda are the example for a solution. And I told you sugar water is a solution because sugar are homogeneous mixture, because all the constituent particles are mixed very well, dissolved very well. But in soil water, see, I took some water and added some soil to it. What happened? These soil particles are settled down in the bottom, right? So the soil water is a heterogeneous mixture because the particles are not dissolved well. It's a heterogeneous mixture. Hence, the soil water is not a solution. Clear? And as I told you, sugar to water, I got sugar solution, right? And water is the solvent, sugar is the solute. Now, this solution contains only two components in it. One solvent and one solute, water and sugar. Only two components. Whenever a solution contains two components in it, I can call that solution as the binary solution. As I told you before, solvent is the component which is present in the largest quantity, right? So, the solvent will determine the physical state of solution. For example, if the solvent is in gaseous state, solution also will be in gaseous state, and that solution is called the gaseous solution. If the solvent is in liquid form, solution also will be in liquid form, and the solution is called liquid solutions. If the solvent is in solid state, solutions also will be in solid state, right? And the solution is called solid solutions. These are the three types of solutions: gaseous solutions, liquid solutions, and solid solutions. Let's look into this table. The solution must be a gaseous solution if the solvent is in gaseous form, right? Yes, I took all the solvent as gases, so the solution will be in gaseous form. And I took three different types of solute: gas, liquid, and solid. Let's look into the examples of these type of solutions. First, I added a gaseous form of solute into the gaseous solvent. A mixture of oxygen and nitrogen gas is an example for these type of solutions. And I added a liquid state of solid into a gaseous solvent, chloroform mixed with a nitrogen gas is an example for that. Because chloroform is in liquid form and nitrogen obviously is a gas. And I got a gaseous solution. Now, I added a solid solute to a gaseous solvent. Camphor in nitrogen gas. Camphor is in solid state and nitrogen gas. I got a gaseous solution. Now, the liquid solutions. So, the solvent must be a liquid. Solvent must be a liquid. I took 3 different types of solute. First, I added a gaseous solute to a liquid solvent. Oxygen dissolved in water is an example. Next, liquid into a liquid. Ethanol dissolved in water is an example. Next, solid in liquid. That is, glucose dissolved in water or sugar dissolved in water or salt dissolved in water is an example for liquid solutions. These type of solutions we are using in day-to-day life, right? Yes, this is an example for liquid solutions. Next thing, solid solutions. So, the solvent must be in solid state. And I took 3 different types of solute too. And I took gaseous solute into a solid solvent. Solution of hydrogen in palladium is an example. Next, liquid in solid. Amalgam of mercury with sodium. Next, solid in solid. Copper dissolved in gold. Both are in solid state. So, I got a solid solutions. These are the 3 types of solutions: gaseous, liquid and solid solutions. So, we are clear about what is a solution and what are the 3 types of solutions, right? From the next video, we are going to discuss some equations to express the concentration of solutions. Until then, bye-bye.